In the 1950s, a time when the world was gripped by Cold War tensions and the race for technological supremacy, a peculiar French aircraft took shape that looked more like a prop from a science fiction film than a military jet. The SNECMA C.450 Coléoptère, meaning beetle in French, was a bold, bizarre, and ultimately doomed experiment in vertical takeoff and landing aviation. Its story is one of audacious innovation, engineering ambition, and a fleeting moment of flight that captivated the imagination of aviation enthusiasts worldwide. The 1950s were a period of intense military innovation, driven by the fear of nuclear conflict. War planners believed that a future European war would begin with devastating nuclear strikes targeting airfields, command centers, and communication hubs. Traditional air forces, reliant on long runways, were vulnerable to such attacks. The solution? Aircraft that could take off and land vertically, dispersing to remote locations and evading destruction. This concept, known as vertical takeoff and landing, became a global obsession, with the United States, the Soviet Union, and European nations racing to develop viable designs. In France, the Société Nationale d'études de construction de moteurs d'aviation, SNECMA, took up the challenge. Embarked on a project to create aircraft that could operate without runways, offering rapid response capabilities and strategic flexibility. The result was the C.450 Coléoptère, a machine that pushed the boundaries of aeronautical engineering and defied conventional aircraft design. The Coleoptere's most striking feature was its annular wing, a cylindrical, donut-shaped structure that enveloped the fuselage, unlike the flat wings of traditional aircraft. This concept, pioneered by Austrian engineer Helmut von Zborowski, promised to reduce drag by eliminating wingtip vortices, potentially increasing efficiency and even functioning as a ramjet engine for supersonic speeds. The Coleoptere was a tail-sitter, meaning it rested on its rear, pointing skyward, and used the raw power of its engine to lift off vertically before transitioning to horizontal flight. Its fuselage housed a single SNECMA Adder 101E turbojet engine, delivering 7,700 pounds of thrust, derived from wartime German BMW 003 designs. The airframe, built by Nord Aviation, measured 22 feet in length with a 10.5-foot diameter annular wing. For small triangular winglets, mounted on the wing's outer edge, provided control during horizontal flight, while deflecting vanes in the engine exhaust managed stability during hover. The undercarriage consisted of 4 compact, cast-oared wheels, allowing the aircraft to balance on its tail. The pilot's cockpit was equally unconventional. To accommodate the aircraft's shifting orientation, the pilot sat in a tilting ejector seat that swiveled nearly 90 degrees, keeping them upright during vertical takeoff and landing and aligned with the horizon during forward flight. Air intakes on either side of the cockpit fed the turbojet, giving the Coleoptere a sleek, futuristic appearance. With a thrust-to-weight ratio of 1.4 to 1, the aircraft had the power to defy gravity, but controlling it would prove to be a formidable challenge. Before the Coleoptere could take flight, SNECMA needed to prove the tail-sitting concept. Beginning in 1952, the company developed a series of wingless test rigs known as the Adder Volant, Flying Adder. These prototypes, designated C.400 P1, P2, and P3, were essentially turbojet engines mounted vertically with basic control systems. Their purpose was to test the feasibility of vertical takeoff, hover, and landing using jet thrust alone. The Adder Volant series progressed from 1955 to 1957, powered by the 6,400-pound thrust Adder D engine. Each rig grew more complex, incorporating improved control mechanisms and stability systems. The C.400 P3, the most advanced, demonstrated the ability to lift off, hover, and land safely, providing critical data for the Coleoptere's development. While the results were promising, they also highlighted the inherent difficulties of controlling a jet-powered, vertically oriented aircraft. Nevertheless, SNECMA pressed forward, confident that a winged prototype could overcome these challenges. By early 1958, the C.450 Coléoptère prototype, designated C.450-01, was complete and delivered to Melun-Villaroche Aerodrome for testing. Initial tests focused on tethered flights to ensure the Coleoptere could lift off and hover safely. On April 17, 1959, the aircraft performed its first tethered hover, suspended by cables to prevent uncontrolled movement. The test was a success, demonstrating that the Adder 101E engine could generate sufficient thrust to lift the 3,000-kilogram aircraft. Encouraged by these results, SNECMA prepared for untethered flights, a critical step toward proving the Coleoptere's viability. On May 3, 1959, the Coleoptera achieved a historic milestone, its first free hover. Piloted by test pilot Auguste Morel, the aircraft rose vertically, hovered for 3.5 minutes, and landed safely. The flight, though brief, was a triumph, validating years of research and engineering. Over the next few weeks, the Coleoptera completed several more stationary flights, reaching altitudes of up to 1,000 meters. Each success brought SNECMA closer to the ultimate goal, transitioning from vertical to horizontal flight, a maneuver that would make the Coleoptera a true VTOL aircraft. However, these early flights also revealed significant challenges. The Coleoptera was notoriously difficult to control, especially during hover. The deflecting vanes in the engine exhaust provided limited stability, and the aircraft tended to oscillate, requiring constant corrections from the pilot. The annular wing, while innovative, did not provide the expected aerodynamic advantages, and the small winglets were ineffective at low speeds. Despite these issues, SNECMA remained optimistic, believing that refinements could address the aircraft's shortcomings. On July 25, 1959, the Coleoptera embarked on its 9th flight, a test that would push the aircraft to its limits. The objective was ambitious: lift off vertically, transition to a 36-degree angle for horizontal flight, return to hover at 2,000 feet, and descend vertically. This maneuver, known as the transition, was the holy grail of aviation, requiring precise control and stability. Auguste Morel, an experienced test pilot, took the controls, aware of the risks but determined to prove the Coleoptera's potential. The flight began promisingly, with the Coleoptera rising vertically as planned. However, during the transition to horizontal flight, disaster struck. The aircraft became unbalanced, tilting to nearly 50 degrees and losing altitude rapidly. As Morel struggled to regain control, the Coleoptera began oscillating violently in all 3 axes: pitch, yaw, and roll. Unable to stabilize the aircraft, it plummeted toward the ground, tumbling uncontrollably. At just 150 feet above the ground, Morel made a split-second decision to eject. The tilting ejector seat, designed for such emergencies, propelled him clear of the aircraft, but the low altitude left little time for his parachute to deploy fully. The Coleoptera crashed in a fireball, destroyed beyond repair, while Morel landed heavily, sustaining serious injuries. The crash marked the end of the Coleoptera's brief career, as funding for a second prototype was never secured. The Coleoptera's failure can be attributed to several factors, both technical and strategic. The annular wing, while theoretically promising, proved impractical for operations. It offered limited lift at low speeds and complicated control, especially during hover. The small winglets and exhaust vanes were insufficient for stabilizing the aircraft, making it a nightmare to pilot. The transition from vertical to horizontal flight, a critical requirement, exposed these flaws dramatically, as the aircraft lacked the aerodynamic stability to execute the maneuver safely. Moreover, the tail-sitting configuration itself was inherently flawed. Pilots faced significant challenges in judging distance and alignment during vertical landings, exacerbated by the Coleoptera's tendency to spin uncontrollably. The swiveling cockpit, while innovative, added complexity without fully solving visibility issues. Compared to later designs, such as the British Harrier jump jet, which used pivoting jet nozzles and conventional wings, the Coleoptera was a compromise that sacrificed payload, range, and ease of operation. Though the C.450 Coléoptère never progressed beyond its experimental phase, its legacy endures as a testament to human ingenuity and the willingness to challenge conventional wisdom. The aircraft's annular wing and tail-sitting design, while unsuccessful, pushed the boundaries of aeronautical engineering, providing valuable lessons for future VTOL projects. The C.450 Coléoptère was a daring leap into the unknown, a machine that embodied the spirit of 1950s innovation and the relentless pursuit of progress. Its annular wing, tail-sitting design, and swiveling cockpit were radical departures from convention, reflecting a willingness to dream big in the face of uncertainty. Though it flew for only a handful of minutes and ended in a fiery crash, the Coleoptera's story is one of courage, creativity, and the inevitable stumbles that paved the way for future breakthroughs.